So let's see what we have today. We have a fidget spinner with us. Fidget spinner is basically a spinning toy, but quite popular nowadays with the youngsters. It has three boomer shaped arms. Basically, I am not quite a fan of fidget spinner, but I got this fidget spinner from one of my younger cousins. So I thought to make a video about how the fidget spinner works. This is a rough figure of fidget spinner. Fidget spinner has three arms. The arms are arranged in a boomerang shape, not quite boomerang shape because it has a bulge here, but it is approximately in boomerang shape. The three arms has a heavy weights at their ends and axis at the center. The axis is surrounded by the ball bearings. The ball bearings reduce the friction by changing the static friction into the rolling friction. We have three basic kinds of frictions: static friction, kinetic friction and rolling friction. The rolling friction has the minimum value and the static friction has the maximum value. So when we add some ball bearings around the axis through which we hold the fidget spinner, this is the axis through which we are holding the fidget spinner. It has ball bearing around it. Now the distance between the axis and the weight is R, and we are applying some F amount of force on its corner, on its end, at the weights. This force at a distance R from the axis will generate a torque which will be the multiple of force applied and the distance from the axis. As the torque is applied, it will generate a rotational motion around the axis of the fidget spinner. As the direction of force is this, so fidget spinner will rotate in a clockwise direction. Torque is basically the rotational analog of force. As force creates a linear motion, similarly torque creates a rotational motion. How the fidget spinner works and what is the importance of these weights at the end has a direct relation with the moment of inertia of the shape. Moment of inertia is the rotational analog of mass. Rotational analog of mass means that in a linear motion, how hard it will be for a body to stop when it's in motion, or how hard will it be for a body to start its motion when it is at rest, depends on mass. If body has a higher mass, then it will be more difficult to stop from moving, and if a body has lower mass, then it will be easier to stop it from the moving. Similar is the concept with moment of inertia. If the moment of inertia will be very high, then it will be difficult to rotate a body or to stop a rotating body, and vice versa. If we turn the fidget spinner into a triangular shape with mass uniformly distributed, then more mass is spread out. As the mass will be spread out quite enough, so it will have a higher amount of moment of inertia. As the moment of inertia is high, so more amount of force will be needed to rotate the fidget spinner in this shape, and it will stop even sooner. So to reduce the moment of inertia, we have distributed the shape in this manner, which has weights at the end and some mass is situated just at the axis. It reduces the moment of inertia quite enough to keep the fidget spinner rotating. So this fidget spinner is quite a simple toy with just a basic application of rotations. Still it is interesting, and I don't know who made this fidget spinner at first. It was good to think of it. In this fidget spinner I have a light here, so it looks quite interesting when it rotates. I am not quite good a fan of fidget spinner. Still I thought many people used to play with this, so I thought it's good to make a video on fidget spinner. Thank you. Keep rotating.